An airplane flying horizontally at a velocity of 50 meters per second at an altitude of 125 meters. It drops a package to observer on the ground below. Approximately how far will the packet travel in the horizontal direction from the point that it was dropped? Let's illustrate that with a photo. Airplane dropping something, projectile motion. You can understand the situation, right? What happens
Yes.
in this case? Yeah, an airplane dropping something. Yeah.
Yes.
Yeah, we didn't study that. This thing is called projectile motion. Okay. It means that a motion happens in two dimensions, horizontal dimension and vertical dimension, like dropping a thing, uh, throwing a thing horizontally, and it fall as a curve like this. Okay. We normally see it like throwing a what's it called? Basketball. No, basketball. We throw it up like this, huh?
Yes.
Basketball. I'm looking for the word about a game that Japanese people love playing. They hit the ball with a light rod. What's it called?
Baseball.
Yes, exactly, exactly. Baseball. Yeah. So, for example, a baseball flying or a um, basketball being thrown. Okay, uh, or shooting a normal football. So there are many examples of this kind of motion. They're called projectile motion. Projectile motion, the motion happen in two dimensions: horizontal dimension x and vertical dimensions, direction y. Okay.
Yes.
To answer this kind of problem, we need to use the series of equation. Let me open the formula booklet that you are allowed to bring to the testing room. AP Physics 1. I'm looking for the equation to solve this problem. This is one of it. But this is for the horizontal component. If an object moving with a constant acceleration, in this case, the vertical movement, vertical fall, vertical motion in the vertical direction or y, is a free fall, is um, a constant accelerated motion. It means that the acceleration in this direction, vertical direction, is constant, and its value is the free fall acceleration, which is 9.8 meter per second square. Okay, a
Yes.
constant accelerated motion, with the acceleration g equal 9.8 meter per second square. This thing's called free fall acceleration. And for constant accelerated motion, you have the equation for the vertical position of this object falling. Okay, it is equal to the initial position. It is usually zero because we chose the starting point where the object start falling, being dropped out of the airplane to be zero. So this thing is normally most of the case is zero. Okay, but
Yes.
initial vertical position added with the initial vertical velocity ut according to this equation.
Yes.
Okay. Um, vertical. So I'm going to write VOY, vertical initial velocity, plus 1/2 of this G and the square of time. Note that we have to choose a direction to be positive. If it falls down like this, in this case, the airplane dropping an object, the downward direction is chosen to be positive, okay? So that the G here is positive 9.8 and the initial horizontal velocity in this case is zero because it is thrown horizontally. The initial velocity is horizontal, not vertical, okay? So this vertical
Yes.
component is initially zero, in this case, the airplane.
Yes.
And besides, the vertical velocity of this object vary with time uh, and described by this equation: initial vertical velocity v0y and add it with the g and t. G is 9.8, and that equation is here. Okay, initial velocity, the vertical velocity changes linearly like this. This is the vertical velocity, Vy. This is the time, and the vertical velocity increases like this with the slope to be the acceleration 9.8, okay, meter per second square.
Yes.
So this is the equation for the vertical motion. We need two other equations for the horizontal motion. Horizontal motion. Please take note when I'm writing. Okay, horizontal motion. Of course, I will send you the PDF file of this note later, but taking note yourself is necessary. Vertical motion is constant, meaning the velocity Vx is constant, which is equal to the initial horizontal velocity. Okay, initial horizontal velocity. The reason it is constant is because for this projectile motion, and only in the limit of our syllabus, we ignore the air resistance, negligible air resistance. It means that there is no horizontal force. The only force acting on this projectile motion is the gravity. Only gravity, the weight, the attraction, the Earth, acts on the objects, and air resistance is negligible. Okay, air resistance. So horizontal velocity is constant. Then horizontal position x is determined by x0 and added with the v0x, which is initial horizontal velocity, multiplied with the time. So using these equations, we can solve this problem. The question asks how far the packet traveled horizontal direction from the point that it was dropped. It means that the question is this displacement, this distance, horizontal distance. This is the position where it was dropped, huh?
Yes.
Horizontal direction, horizontal distance there. The question asks of this thing, x. Okay, we change the color.
Yes.
X. To find that x, we need to use this equation here. Initial position x0 is 0. Okay, initial horizontal velocity is 50. Okay, 50. So to find x, we need to find the time, and the time will be calculated from this equation. Okay, so x here equal to v0x multiplied with time. The v0x is 50 meter per second, and the time is calculated by solving this equation. The height y is 125 meter.
Yes.
Yeah, 125 meter. This is y, okay, equal to y0, which is 0. Initial vertical velocity is also 0, so it is only 1/2 of 9.8 and multiply with the time square. Therefore, we can solve the time, find the time from this equation and plug back into the first equation here and find the distance x. Okay, so the rest, please do that yourself with the time, plug back into the first equation. So if we understand and we can remember these things, the two equations here, the first one and the second one, we can answer this multiple choice question within 1 minute. But it's require a lot of practice so that you can actually understand the projectile motion and solve the problem quickly. Not easy. Normally, for most students studying any curriculum, IB or A level, they have to spend a few periods, 4, 3, 5 periods to really master the basic thing of projectile motion.
Yes.
Okay, so what is the time? 125 multiplied with 2 and then divide 9.8, huh? And then take the square root. The time is 0.5154. Okay. The time is 0.5154 second, and then plug back into the first equation. The horizontal distance is 50 multiplied with this time, multiplied with 50, and the answer is 25.77, or we can round to 25.8, or even 26, 25.8 meter. And so the answer of this is no answer. Sorry, there's something wrong. Something wrong. Let me. Okay, calculate the time again. 124 and 25 multiply with 2 and then divide 9.8. Multiply with 2, divide 9.8, and then square root. Okay, sorry, my fault. The time is 5.05 second.
Yes.
5.05 second, and plug back into the initial equation for the distance x. Multiply with 50. The distance x is 252.5. So the closest value to the answer is 250 meters. Okay.
Yes.
250 meter. Okay. So this is the solution for the first question. There's another quicker way. It's like a trick if you really understand it. The projectile motion as follow. Change to another color. Because we know the equation for the vertical displacement is y equal 1/2 gt squared. We can take g approximately 10. Okay, and y here is 5t squared. It means that the vertical position is proportional to the square of time. So it means that when the time is 1 second, let me refresh the page. Recently, the board has a problem. It does not show the tip, the position of the pen. I have to like refresh it. Okay. So when the time is 1 second, the displacement, the vertical displacement, vertical distance that it falls is the falling distance. Okay. Falling distance y will be 5 times 1 square. Okay. This is 1 second. And then 2 seconds, it is 5 times 2 square, which is 4, meaning
Yes.
20. 3 seconds, 5 times 3 square, 5 times 9, 45. 4 seconds, 5 times 4 square, 16 times 5, 80, 80 meter. 5 seconds, 5 times 5 square, 125. You see, this is a beautiful number because it is exactly equal to the given height, the given height of the airplane. So if we understand like this, we can quickly determine the time to be 5 seconds, okay, instead of using this equation. And then finally, just multiply with 5 seconds with the horizontal speed, which is 50 meter per second for horizontal speed, multiply with the time 5 seconds. So the answer is 250 meter. Okay, so please take note of that. This is like a trick that you need to do in AP or ACT or the old SAT too.
Yes.
Okay, that is projectile motion. What is the next question that you find?
Number 8.
A play kicker kicks a football at a velocity 10 meters per second from a tee on the ground at an angle 30 degrees from horizontal. This is also projectile motion. Okay.
Yes.
Moving in 2 directions is a curve like this. Approximately how long will the ball stay in the air? Okay, one more thing that we learned in this projectile motion part. %. Okay. this object is kicked with an angle of 30 degrees, but it's not necessarily 30 degrees. It could be any other value of the angle theta, okay, 30 degrees.
Yes.
The initial velocity vi, or we can vu, initial velocity. Let's say vi, because it is in agreement with the given formula booklet, formula sheet.
Yes.
Initial velocity. To calculate the time it stays in the air, it is also called the time of flight. Time of flight. It goes to the top here, and then full
Yes.
scale,
Yes.
Not a beautiful drawing. Anyway, the top here. In the vertical direction, vertical velocity, Vy were described by Vy0y initial velocity and added with the free fall expression G9.8. You can take 10 to simplify the calculation, multiply with T. In this case, we would choose the vertical upwards direction to be positive, and therefore the velocity, initial velocity here is positive, and G is negative, okay, negative 9.8. So at the top position of this path, the Vy will become 0. It must reach 0. It cannot go even higher if it's the top, okay? So Vy is 0 at the top, okay? It equal to the initial vertical velocity here, which is determined by V initial multiplied with sine of the angle theta. Angle theta. Here, you've learned trigonometry, have you? Haven't you?
Huh?
Have you learned trigonometry?
Yes.
Okay. Any vector we can resolve, we can consider like one vector is made up by the two other vectors in the two direction, horizontal direction, v0x here and v0y here, okay?
Yes.
They will make a triangle here, vy, okay?
Yes.
The initial velocity v0 is the hypotenuse of this triangle.
Yes.
The opposite side is Vy, and therefore we have sine of this angle theta is the opposite over hypotenuse, so quatre, okay? So quatre. So this is Vy over V0, and therefore Vy is here V0 times sine theta. Vy0. This is V0y, meaning initial vertical velocity. And this is initial horizontal velocity Vox. V initial multiplied with sine theta, plugging here, okay? And then minus 9.8 for G, minus 9.8 G times T. And therefore we can find the time to go to the top. Term flying to top, flying to top, which is here, equal to moving this thing to the left. We have negative, negative divide negative becomes a positive, okay? It is V0 times sine theta and divide G, okay? The time it fall back to the ground will be exactly equal to this time. The time falling back to the ground is the same. Falling back to the ground. Exactly the same. Again, it is only the same when the air resistance is negligible. And we only consider that case. We do not study the case when the air resistance is present, is not negligible. Okay, that is for university level. So exactly the same, and therefore, so the total time of the flight, it stays in the air of the flight is 2 times of that. T is 2 times of this T, let's call T1, okay?
Yes.
Meaning 2 sine theta over G. And in our problem, kicking a ball, the angle is 30 degrees.
Yes.
The initial velocity, 2 times initial velocity. Initial velocity is 10 meters per second. 10. 2 times of 10. Okay.
Yes.
Right behind, so that's a bit more beautiful. 2 times of 10 multiply with sine of 30 degrees and divide G. We can take 10 to simplify the calculation. So 2 times sine 30 is 1/2. So 2 times 1/2 is 1 second. Okay.
Yes.
The answer is 1 second. A little bit less than 1 second, greater than 1 second, because G is less than 10, 9.8. So the closest value is 1, not 0.8, okay? Because 9.8 is just a little bit below 10.
Yes.
The answer is 1 second, okay?
Sure, but
Simplify. Huh?
I don't understand why T is 2 times T1.
Here I told you here, the time for going to the top is T1, and then it takes the same time another T1 to fall back to the ground. So you added the 2 times of the time, huh? You add another T1 for falling down.
Yes.
1 T1 equal to V0 sine theta over G for going up, going to
Yes.
top.
Yes.
And another T1 the same for falling down to the ground, this initial height.
Yes.
Okay. Let's check the formula booklet if this equation is given. I don't think so. Meaning there are a lot of other things that you have to learn and remember instead of looking for the answer in this formula sheet. Very limited equation, huh?
Yes.
Not many. Physics 1, only 2 pages. Not much. Okay. There. So the only way is practicing. I will send you many more, assignments. Okay.
Yes.
Okay. So this is the solution. Please make a Microsoft account so that you can access to this board. It takes only like 2 minutes to make an account. Huh? Yeah. It's a link to the board so that you can navigate whenever you want to see on the board, and even write on it if you have a tablet, a pencil. So if you remember the equation, that time, how long the time is 2 times, decrease the thickness here, 2 times of V0 sine of the angle divided by G, 2 times of 20 times sine of 10 with 10, 30 degrees divide 10, approximately equal to 1 second. So 125 meter, it takes 5 seconds, huh? Because the height is proportional to the square of time. 125 equal 5 multiplied with 5 square. The time is 5 seconds, huh? So the horizontal distance x is 5 seconds, 50 meter per second, multiply with 5, 250 meter. So you can only do it that quickly if you really understand the behind the equations of this problem, projectile motion.
Yes.
Okay. Have you done like taking note? What is the next question?
Number 13.
Yeah, change the allowance of this thing. Viewer, editor, copy the link. Thing. A person dropped a stone down a well and hears the echo 9.8 seconds later.
Number 13. Number 13.
Yeah. A ball throws straight upward with an initial velocity of 30 meters per second straight upward. How much time does it take to reach its maximum height? Okay, this motion is also constant accelerated motion, and the acceleration is 9.8 meters per second. Okay, upward initial velocity, only gravity acts on it.
Yes.
Gravity acts on it, and we know that this gravity is W the way equal to G times the mass of the object, where G is 9.8 meters per second square, and sometimes you can take 10 to simplify the calculation.
Yes.
So roughly equal to 10. Thrown upward with initial velocity 30 meters per second. So because the acceleration is downward, this G is downward.
Yes.
Always. Okay.
Yes.
It is always downwards, and therefore it will decelerate this ball motion G. It will slow down the motion. We make V decrease, huh? You
Yes.
make V decrease. It decreases by 10, approximately 10 meters per second each second. It means from 30 meters per second decrease to 20 in 1 second, decrease to 10 in another second, and decrease to 0 at the top after 3 seconds. Okay.
Yes.
3 seconds. Or in other words, you can use the first equation here. The final velocity, similar with the projectile motion, the velocity at the top is 0. The initial velocity is 30, okay? And the acceleration is minus 10. So V at the top, which is 0, equal to initial velocity 30, and add it with minus 10 of the acceleration multiplied with time, and therefore the time is 3 seconds. Okay. The questions: how much time does it take to reach maximum height? This is the answer: 3 seconds.
But why the velocity in the top is 0?
It cannot remain a certain value because when it is not 0, it's still moving up, right? Let me show you a video about that. Everything, when you throw it upward, of course, it will go to certain height. It cannot go forever, huh? Only in empty the space outer universe. Okay. Throwing object up. Okay, here. Slow motion. Here. Here, there. Temporarily, velocity decreases to 0 right before changing direction and falls downward again.
Yes.
Right?
Yes.
There. the instant that it reaches the top, the velocity, what is called instantaneous velocity at the top is 0. Instantaneous velocity means the velocity at an instant calculated by the displacement in a tiny fraction of a second, like 1/100th of a second. Okay.
Yes.
At the top, velocity is 0, so we can, or you can understand it this way: from 30 to 20 to 10, and finally to 0. It takes 1, 2, 3 seconds. Okay.
Yes.
If you know the frame rate, no, it's not necessary. I was intended to use a software to measure the displacement and the acceleration of this motion, proven to prove that it is approximately 9.8. But we don't have time for that, and it's not a must in this curriculum. Okay, next one.
Oh, number 16.
16. Object position with time depicted in a following graph. Based on the graph, at which time points will the object velocity be closest to 0? Points closer to 0. We say the chain of x is increase and then decrease, increase and decrease. It is approximately an oscillation, meaning it moves backward, up and down, or left and right. Okay, because the position increase and decrease.
Yes.
Oscillation. The velocity will be 0 at the top and the bottom of this position graph, because velocity is determined by the rate of change in position. The rate of change in position. It means delta x, which is the position change, over delta t, and instantaneous velocity, you need to take the time to be very close to 0. Have you learned the limit in math? Limit.
Yes.
Okay, so the limit of this ratio when the denominator approaches 0 is the instantaneous speed, which is the tangent, the slope of this graph. Okay, the slope, and therefore at the peak, the peak here, and
Yes.
the bottom, the velocity is 0. Okay, it means that it's about 1, a little bit greater than 1, but the closest value in the answer is 1 second and 3 seconds. Okay, the answer is 1 and 3 here. Okay, the slope of the displacement graph, position graph, is the velocity. Okay.
Yes.
16. Putting it here because I will export the file as a PDF file and send you later. Next one.
Yes.
18.
No, 17.
Cannonball is launched at an angle and travel above the flat ground. At what time point did the projectile reach its maximum height? What time? So looking back at the projectile motion part here, the time it goes to the top here, T1. T1 is determined by V0 sine theta over G. So projectile reach its maximum height. What time point? Angle travel. Using the equation, the time is B sine theta over G. Travel about the flat ground to its maximum height. 1/4 total time the air, 1/2 the total time, okay? Because the total time of flight, total flight time, this is the time to top, is 2 times that, the total time of the flight is t equal to 2 times of the for time to go to the top, huh? V0, V0 sine theta over g. So the answer is 1/2. 1/2. It is a theoretical question. Okay.
Yes.
What's the next one?
Oh, no more question.
So please do it yourself, like the next 5 questions in this document.
Yes.
We'll spend like an hour for each session for the multiple choice question and 1 hour left for the free response question. Okay.
Yes.
Do you use Zalo? An app many Vietnamese people use? No.
Oh, no. No.
Okay, so you can take a photo of your work, how you solve the problem, and send to me on Kakao Talk.
Yes.
Oh, this is a link for the formula sheet. When Hung Jo studied with me, he did a lot of work, self-study himself, answering multiple choice question and first one question, and only asked me the difficult one. But he different from you because he was much older, like 2 years older than you, at the 13 year, huh? And
Yes.
and also he was extremely good at math and very smart.
Yes. Sure, I don't know 21.
Velocity time graph by the object displacement relative to the initial time. Okay. The question is displacement.
Yes.
Remember that displacement is different from distance. For example, you move from A to B in a arbitrary path like this. This
Yes.
is the distance. The
Yes.
distance. But the displacement is simply a vector from A to B.
Yes.
Difficult to draw a straight line. Vector from A to B. Displacement. And beside, displacement can be positive or negative. Can be negative. To do this kind of problem, a similar problem relating to a velocity time graph, and with the two parts of the graph above the horizontal axis and below the horizontal axis. Okay, the
Yes.
area of each shape under the graph here is the distance that the object moves.
Yes.
Or we can call this distance either positive displacement when the area below here is a negative displacement. Negative displacement. So to answer this question, you need to calculate the two areas of the trapezoid, upper trapezoid and below trapezoid, and subtract them. Subtract the positive one by the negative one. Okay. Displacement. Calculate the two areas and then take the bigger one on the top, subtract the lower one, smaller one on the bottom.
Yes.
Trapezoid area, remember the equation?
Yes.
Area of the trapezoid is 1/2 of the big space A and the small bay B multiplied with the height.
Yes.
Okay, so please calculate that and tell me the answer.
Or 8.
meaning 3 meter.
Yes.
Checking the answer in this 21. Yes, correct. You see the same method.
Yes.
Yeah, the two trapezoid areas and subtract them. But the thing here, it has a negative speed. Yeah, make -2, implying it's a negative displacement.
Yes.
Below the horizontal axis is negative. Okay.
Yes.
Because the velocity in this part of the graph, or the part below the graph, the velocities are zero, less than zero, negative velocity, huh? Therefore,
Yes.
the displacement is also negative. Negative. Let me change like a more pink. Negative velocity. Okay.
Yes.
21. Please move on. Do it yourself. Question 22.
Yes. I don't understand this one.
22. Projectile launched with an unknown velocity and angle 30 degrees from horizontal of level ground, which the following statements is true. Like kicking a ball, huh, from the ground. If like 30-degree angle. Statement A. Horizontal component velocity is less than the vertical component. Okay. Horizontal component is Vx equal V initial multiplied with cosine of 30 degrees. And cosine 30 is greater than the sine 30 degrees when you calculate the vertical velocity Vy, huh? Equal to this V0 initial.
Yes.
So this statement A is already correct, and we don't need to consider other thing, luckily. But if we want to figure out why other things B, C, D, E are wrong, okay, the horizontal component velocity is greater than vertical. That's wrong. It is completely opposite to A, huh? A is wrong, then
Yes.
B. A is right, then B is wrong.
Yes.
Both horizontal and vertical component velocity equal. It is only equal when the angle is 45 degrees, because sine of 45 degrees is the same as cosine of 45 degrees. Okay.
Yes.
The horizontal component velocity used to calculate the time the projectile is in the air. No, the vertical, not horizontal. Vertical, not horizontal. So that is the reason why this thing is wrong, because the time it is in the air is calculated by 2 times V initial multiplied with sine, and sine is the vertical component, okay, divided by G. You see, because I do this problem like 10 years, thousands of questions, therefore I remember the equation.
Okay, can you say it again? Internet connection.
Doesn't matter. Okay. The equation for calculate the time in the air relate to the vertical velocity, not the horizontal velocity, and therefore saying that using horizontal is wrong. Okay.
Yep.
Vertical component velocity is used to calculate the range of the projectile, both things, vertical and horizontal. Because the vertical component will allow you to calculate the time, the range is calculated by, I didn't tell you in the theory on this board. So this is the new equation for the range. The range is the horizontal speed, Vx multiplied with the time, okay? Vx is V0 times cosine theta multiplied with the time 2 times of V0 times sine theta over G. This is the equation for the range, okay? And we can simplify this equation, 2 times of V0 sine times cosine. There's an equation in trigonometry like theorem or a problem, an exercise that require you to prove. And the result is that 2 times of sine of an angle multiplied with the cosine of that angle is equal to sine of 2 times of that angle. Okay? And therefore, this thing is V0 times sine of 2 theta divided by G. This is the range. Okay. Please write this equation for the range in your notebook. On your notebook.
Yes.
And that definitely not in the formula sheet. The answer for this angle 30 degree, the horizontal component is greater than the vertical component. The two components are only equal when the angle is 45 degrees. 23. From rest, a ball is dropped from the top building, takes 4 seconds to hit the ground. Approximately how tall is the building? 4 seconds. Remember the thing that I told you about the proportionality between the height it falls or the distance it falls with the time? The distance it falls is proportional to the square of time. 1 second, yes. 2 seconds, 3 seconds, and 4 seconds. The distance will be 5 multiplied with 4 square, 16 multiplied 5.
Yes.
80 meter, huh? Approximately yes. 80 meter.
Yes.
But there's no answer like 80. 4 seconds, approximately how tall? 90. It takes 4 seconds. Wait, 4 seconds, 4 square, 16 multiply with so yeah, with 5 is half of 10, huh? Half of yes. 10. So 80, the closest value is 90. 90. Okay, let's check the answer. 23, 9.8 multiplied with 4 square. 4 square is 16. 16, then half of this is like half of 10, which is 5. 6 times 5 is 0, and remember 3. Wait, 1 times 5, remember that is 80, not 90. I think that is a typo, typo in this book. Instead of 9, they type 9. Instead of 8, they type 9. Yeah. But close it. So if we cannot find a exact value, we choose the closest one. Okay.
Yes.
Don't be afraid of making a mistake and lose the mark, because you lose the mark anyway if you don't choose an answer.
Yes. Or D.
Object D. If the positive direction is forward, and then which object is moving backward at a constant velocity? Which object is moving backward?
D.
Constant velocity. X positive outward velocity with X decreases. Yeah, the negative gradient, correct? Yeah, good job. Negative backward, negative gradient, huh? Negative slope.
Yes.
Slope of X term graph.
Oh, I don't know this one.
Projectile, same velocity, different angles, relative to the ground. In measuring each projectile with angle pair have the same range. Okay. The equation for the range here.
Yes.
I will write it again. You need to write it like many times to remember that.
Yes.
Again, the range is horizontal speed, which is constant, multiplied with time. Horizontal speed is v0 times cosine theta. And the time is 2 times of v0 times sine theta over g. So you have cosine and sine in this equation.
Yes.
And the two angles which are supplementary, right? Is that the word? Meaning the two angles which add up to be 90 degrees. They call supplementary angles, right? Supplementary angles. Yeah. Wait. Measure up to. Oh, sorry. There is not supplementary. It's called complementary. Complementary angles.
Yes.
30 degree and 60 degree complementary triangle. With the two complementary angles, you have sine of 30 degrees equal to cosine of 60 degrees, and vice versa. Cosine of 30 degrees equals sine of 60 degrees. And therefore, for any two angles which are complementary, meaning their sum is 90 degrees, the range will be the same. Okay, so the answer will be 30 and 60 degrees. Let me show you a simulation, a diagram. Projectile motion, range, same range, different angle. Yeah. With the 30 degree, you have a lower orbit, lower path, and landing here. With 60 degree, you have a higher path. It takes much longer time, but the range will be the same. Okay.
Yes.
And the maximum range will be 45 degrees. I don't know that because this equation, the range, we can simplify the equation as I explained above. Cosine multiplied with sine of the same angle is sine of 2 theta. Sine of 2 theta times v0 and divided by g. The range will be maximum when the sine is 1. The maximum value of sine is 1. Okay. R is maximum when the sine of 2 theta is 1. And
Yes.
it is only 1 when this angle is 45 degrees, because sine of 90 degrees, 2 times of 45 degrees is 1.
Yes.
Sine of 45 degrees, the maximum range. Yeah. Or any other angle which are complementary, like 20 and 70, 25 and 75, 15 and 75, etc. 30 here and 60, okay? 15 and 75.
Yes.
Maximum range 45. Okay, please do 26. We will complete like 30 questions and then move on to the free response questions.
Number 26 is E.
8. You said E.
Yes.
Distance D, how far does it from rest? Twice elapsed time. Yeah, you're correct. Proportional to the square of time. Y is 1/2 of G multiplied with time square. So double the time, you have 4 times the distance.
Yes.
27.
Well, the answer is B.
Traveling 30 meters per second, the driver applied the brakes. The car uniformly decelerate 9 meters per second square. How far did the car travel before coming to complete stop? Okay, you can check for the equation, which is not here. You can use this equation to calculate the time, huh? And then use the remaining equation, the second equation here, to calculate the distance, huh?
Yes.
30 from 30 to 9. The final value is 9, equal to the initial value 30, and add it with the deceleration minus 9, multiply with the time. So 23, huh? 30 minus 9, 23 equals 90. So the time is 23 over 9. Second, the distance s is initial velocity 30 multiplied with its time, huh? And add it with 1/2, the deceleration minus 9, the time 23 over 9 all square, huh? Okay. 27. Answer 50 meter. Okay, they use another equation, which I will tell you right now. Did you answer 50?
Yes.
Okay, good, good. There's another method. You use another equation, which is not in the formula sheet. That equation is v final square equal initial speed square, and added with 2 times of the acceleration and the distance. Okay, so the distance here is v square minus u square over 2 times acceleration. Okay, v is 9, u is 30, and then acceleration is minus 9. So that we have a negative number on the top and another negative number on the bottom, and divide them, we get a positive number, which is approximately 50. Okay, so this equation, this method is shorter, but the equation is not given in the formula sheet.
Oh no, this one is in formula sheet.
Ah, let me check that. Where is it? Oh, here. Sorry, that's all. Okay, that's it. 27. I think we will temporarily stop for the multiple choice here and move on to the free response. Okay.
Yes.
Let me find a free response questions part. Yeah. Let me send you the link to the document. The name of this thing, test 01, free response test 01. Oh, here it is. Here is the link of the document. Huh? Okay, motion in a straight line. We have the two graphs of velocity and time of the two cars A and B. The velocity time graph represents the motion of two cars A and B. Justify all answers roughly. Which car moving faster at the start of the motion? What's your answer? It is pretty simple.
B.
The car B. The start of the motion, the initial velocity of A is greater here. A started here, higher value than B, huh?
Yes.
So the car moving faster at the start is A.
Yes.
Which car ends up faster, farther from its starting point?
B.
B. Why?
Because the time take longer.
Not necessarily, because if the speed is lower, then the longer time is not certain that the object will travel further. To answer that, you need to use the area. The area under each graph represents the distance that that object travel. The car A travel this distance, the area of this triangle, which is certainly less than the area of the car B. Greater area, okay?
Yes.
B, greater area. So if you want to show the specific answer to make sure that you get the maximum mark when doing the test, you can explain it, because the area under the graph of the car B has is vector than that of the car A.
Yes.
The area under the graph of velocity versus time is the distance that the object travel. Distance. Okay. Question C. Which car experiences a greater magnitude of acceleration? How do we depict, understand acceleration in the graph? What does it mean, acceleration? How does it relate to the graph? It is the slope.
Yes.
The slope of the velocity time graph. So the car A has a greater slope. Greater slope. Okay, meaning
Yes.
the acceleration greater. Another graph below here, position and time, with 4 sessions, 4 parts, 1, 2, 3, 4. The following questions refer to preceding position time graph. Which of the readout of the eastward pointing motion detector, which is the readout eastward pointing motion detector, it simply means that this object is moving eastwards. Okay, eastwards. We use a motion detector to measure its position. Justify all answers roughly. Rank the speed of the object in each of the 4 labeled regions of the graph from fastest to slowest. This is position visit time graph. Yes. Which part has the greatest velocity? Velocity. Again, this is position time graph, and velocity is the slope of the graph. With
yes.
the velocity time graph, the slope is the acceleration. Okay.
Yes.
Acceleration if the graph is velocity. But for the graph of position, the slope is velocity, not acceleration. Velocity. So the part 4 here has the greatest slope. Greatest velocity.
Yes.
And the next one, which one has the second greatest velocity? 3. So the order is 4, and then 3, and then 1, and finally is the part 2. The part 2 here, the slope is 0. 0 slope, meaning the object is stationary. It doesn't move. 0 velocity,
Yes.
0 velocity. 0 speed. Question B, what total distance did the object travel in 12 seconds, including all parts of the motion? How do we find the distance?
20 meters.
Adding all the value, this is 20. You need to add all the value for the 4 parts in 12 seconds. The first part, the object traveled 20 meters. Change the color. The first part, the object traveled 20 meters, and the second part, it does not move. Okay. The third part, it moves from 20 to 40, added with 20 again. So that makes 40. And finally, the fourth part, 20 again. So the total is 60 meters. Okay. 12 seconds. 20 meters for the first part, 0 meters second part, 20 meters third part, and 20 meters for the final part. That total 60 meters. Okay.
Yes.
Read the value on the graph. How far from the object's starting point did the object end up after 12 seconds? How far from the starting point? It means the displacement.
Ah, 20 meter.
Yeah, exactly, 20 meter. How far end up? Take another color. Is a 20 meter displacement. Question D. Which of the following objects could reasonably perform this motion? Baby crawling, sprinter, car on the freeway, a jet airplane during takeoff, and air mobile in petri dish.
Airplane.
I think the speed is too low for an airplane. You see, we calculate the speed by dividing the distance. For example, for the first part, the distance is 20 meter, divide 4 seconds. So that is too slow for an airplane. Sprinter, it is also pretty, wait, 10 meter in 4 seconds. Sprinter, like jogging, running, huh?
Yes.
20 meter in 4 seconds. So that is 5 meter per second. That's fast enough, huh? That is a sprinter.
Yes.
Because the baby crawling cannot be that fast.
Yes.
Car on freeway, 5 meter per second. Wait, 5 meter per second. It could be a car. 12 seconds. But the car cannot like instantly stop, huh?
Yes.
Instantly stop here. Yeah. The more reasonable one, reasonable one is the sprinter running. Question 3. A ball is dropped from rest near Earth. Neglect air resistance. Justify all answers roughly. About how far will the ball fall in 3 seconds?
Or 45 meter.
45. 3 seconds. Multiply with 5, huh? Which is half of 10. We write half of 10 instead. Multiply with the square of 3, approximately 45. Yeah. About. If you want a more accurate result, you can take 9.8 instead of 10. Question B. The same ball is dropped from rest by an astronaut on the moon, where the free fall acceleration is 1/6 that on Earth. In 3 seconds, will the ball on the moon fall? So 1/6 of 10. Instead of using 10, you use 1/6 of 10. Huh? The distance it falls will be 1/2 first, and then 1/6 of g, which is 10, and then multiply with 3 square. But the point is that we don't even need to calculate the distance, only the proportionality, because the distance is proportional to the acceleration. So acceleration is 1/6, and therefore the distance will also be 1/6. Okay, the answer is 1/6. So this is actually not pretty multiple choice. The data table for the question 4. Please read it. I'll go to the bathroom for a few seconds. Initial horizontal speed, initial vertical speed, the time of flight. For projectile launch, preceding data table shows the initial horizontal speed, initial spin time, bring the projectiles by the horizontal distance traveled while in the air. How do we calculate horizontal distance? Multiplying Vx, which is constant, horizontal speed, with the flight time.
Yes.
This is initial horizontal speed. This is the flight time. So, which product is greatest among the four? 80 multiplied 4, 220.
Yes.
50 multiplied with 5, 250. 60 multiplied 4, 240. 40 times 6, the same thing. Okay, so the greatest one is D. And rank it. So the order is D, C, and B and A actually the same.
Yes.
Rank the projectiles by maximum vertical height. So how does this maximum vertical height relate to the initial, relate to which one? Initial horizontal speed or initial vertical speed?
Vertical.
Go back to the note that you take about the projectile. Yeah. The maximum height will relate to the time it flies to the top, which is with T1 time. So the maximum height is calculated by V0 y initial, which is V0 times sine the angle, multiply with this time T1, and then add it with 1/2 of this acceleration and T1 square. The question about the maximum height is not very popular, commonly given, But the point is that it's relate to vertical, horizontal velocity.
Yes.
And therefore, the answer is the one which has the greatest vertical velocity, 80. And therefore, the order depends on the value of the vertical initial speed. The order is from 80, which is D, to 60, B, and then 50, C, and finally 40, A. Okay.
Yes.
Maximum height relate to initial horizontal speed multiplied with time plus 1/2 gt squared. The time relate to the time is V0 sine theta over G.
Yes.
Finally, question C, rank the projectile by the magnitude of the acceleration while in the air. The acceleration is the same, not different at all, and therefore there's absolutely no rank. It's just a weird, silly question because they are the same, so there's no meaning of ranking. What is the color? Okay, acceleration is the same, which is 9.8 meter per second downward. Downwards.
Yes.
Okay, this is the answer.
Oh, can you send this file? I don't have this.
I sent the link already here on Skype, and I write the note on there already here. I just click the save button and would automatically sync on the link, the drive.
But the file is different.
Refresh that. It takes some time to save my file writing.
Oh, can you send it again?
Okay, I will send directly the file. Let me open that here. No, not this one. Wait. Oh, that is different link. Sorry. Just one. Page 5. Multiple choice APP1. Is that this thing? No. What's that? AP Physics 1 multiple choice. A multiple choice here. Okay, here it is. I sent the file directly on this Skype. Okay, here it is.
Okay.
It is also multiple choice. Move on to the free response. So later. Let me search for the question related directly to this project. Kinematics. AP Physics 1. Free response. Okay, here's the link. Save that.
Yes.
AP Physics 1 free response. The first 10 meters out of 100-meter dash are covering 2 seconds by a sprinter who starts from rest and accelerates with a constant acceleration. The remaining 90 meters run with the same velocity the sprinter had after 2 seconds. Determine the sprinter constant acceleration during the first 2 seconds. Okay, try doing that yourself. I think you can do that. Using the equation for acceleration. Find the velocity, subtract initial velocity, and divide the time.
Teacher, can you explain this one?
The sprinter started running and accelerate from 0 to a certain velocity. What's that? Okay, 10 meters. See, accelerate during only the first 10 meter for the total part of the 100 meter. 100 meter. Only the first 10 meters she accelerate, and the last 90 meters she run with a constant velocity. The first question, I determine her acceleration. We will need to use the third equation in the formula sheet here, because we know the distance that she runs, which is 10 meters. So the third equation is v square equal v0 square plus 2 times acceleration and distance. V square, which we don't know, equal v0 square plus 2 times of acceleration and her distance, which is 10. But we do not know the final velocity. Okay, but the final velocity can be calculated. Okay, let me write another row in front of that later. V final equal V initial square plus 2 times of her acceleration and the distance she moved, 10. The initial velocity, let's write S first. Initial velocity here is 0, okay? The distance is 10 meters. The final velocity can be calculated because she moved 90 meters in only how many times? They didn't mention. During the first 2 seconds, we know the time. We know the time. So there is an equation relating the time and the distance, which is the second equation here. second.
Yes.
So the distance s is initial velocity multiplied with time plus 1/2 acceleration multiplied with time. Distance is 10 meter. Initial velocity is 0. Acceleration is what we need to find, and the time is 2 seconds. 2 seconds. Yeah. So from this equation, we can find the time. Find the acceleration a. Okay. Acceleration a. So a is 10 multiplied with 2 divided by 4. 5, huh? d2
Yes.
square. 5 meter per second square. Question B. Determine the sprinter velocity after 2 seconds have elapsed. What equation do we use to answer this? After 2 seconds, what is the velocity?
Third equation.
No, the first one. V after 2 seconds, V initial, which is 0, okay? And add it with the acceleration multiplied with the time.
Yes.
Acceleration is 5. We have just calculated here. 5 multiplied with the time 2 seconds, and the answer is simply 10 meter per second. Okay.
Yes.
Oh, this is from 1982. Let's see if we have some recent paper, huh? 1994. It's so difficult for me to find some recent past paper, but I will keep finding that, even have to pay the money.
Okay.
Ask somebody to purchase the AP recent past paper. But the recent one might does not include like multiple free response question about this topic. This is just a very basic beginning topic, which usually appear in a multiple choice question instead of free response. The
Yes.
free response usually relate to projectile motion. Okay, question C. Determine the total time needed to run the full 100 meters.
Show second.
Total time needed to run the full 100 meter. She had spent 2 seconds to run 10 first meter. For the rest 90 meter, it would take her take that time and divide her speed after 2 seconds accelerating. This is the stable, the constant speed after the first 2 seconds. They keep running with this speed for the last part of the running, which is 90 meter. So the time to run that 90 meter, she runs 90 meter, the last 90 meter is 90 divided by 10, which is 9 seconds. So the total time is simply adding 9 seconds here with the initial 2 seconds.
Yes.
Total time, she run 9 seconds, added with 2 seconds, 11 seconds. That's it.
Yes.
On the axis provided below, draw the displacement with a time curve for the sprinter. Okay, please do that yourself.
Send this in KakaoTalk.
The graph displacement For the first 2 seconds, she accelerates
Yes.
with a acceleration of, what is the acceleration? 5 meters per second square. The final distance is 10 meter. The final displacement is 10 meter. 10 meter after 2 seconds. Well, it is just here, after 2 seconds here.
Yes.
So this point is her position after 2 seconds, and the total displacement is only 10. And it is a curve like parabola, not a straight line. Okay, because the equation of displacement for a constant acceleration motion is v0t plus 1/2 at squared, which is a quadratic equation, and therefore the graph is a parabola. Okay.
Yes.
And then continue her speed. It will be a straight line tangent to this parabola up to 90 at the time here. So you draw a straight line passing through all these points. Straight line. Oops. There's no tool on this software to draw. No, not straight line. It must point to here, 100 meter. Okay, let me change that.
Oh, yes.
Let me try using a ruler to. Anyway, yeah. Oops. There.
Yes.
Straight line moving there. It's difficult to draw it directly there. No way to draw a straight line like that. There. The perfect drawing is that the straight line here is the tangent of the parabola at the end. There. It's like a smooth transition between the parabola and the line. This is so small to be like the curve. Okay. Only this tiny part. This part, the distance, is simply the speed multiplied with time. The next question, 1997. Force displacement, we haven't learned force. Skip that. Momentum, haven't learned. Position, 20 and 5, pretty close, like 17 years ago, 18 years ago. Okay. Let's do this one. The vertical position on an elevator as a function of time shown above. On the grid below, rapid velocity of the elevator as a function of time. Position versus time. We need to somehow convert this position into velocity. The first part of the graph is here. From 0 to 8 seconds, it's a straight line. Position varies linearly, straight line. It means that the velocity is the slope of this part. Okay.
Yes.
And that velocity is calculated by 12 divided by the time 8 seconds. 12 over 8, we simplify that, divide 4, 2, 3 over 4, 1.5, 1.5 meters per second. So that is the constant velocity for the first part. Okay, the first part. The second part, I will change the color. The second part is this part, which is a parabola upside down, upside down. It means that this is the deceleration. Deceleration. Slowing down. Okay.
Yes.
An upward parabola like this, meaning the position change increases like this, the slope increases, meaning the velocity increases, meaning acceleration is positive. Okay, but for this graph is a parabola like this, meaning the slope decreases to 0. That is the deceleration. And we can calculate that average deceleration by the final. Now, to calculate the deceleration there, we use the equation S equal V squared minus U squared over 2A. Yeah, so A is this difference divided by 2S, huh?
Yes.
The distance is from 12 meter to 14 meter, meaning 2 meter. S is 2 meter. Velocity, we don't know. The final velocity here is 0. V2 here is 0 because it's horizontal. Vertical position is 0. Okay.
Yes.
Vertical position. How does an object can stop moving upward, like for 10 seconds like this? Elevator. Yeah, it can stop somewhere, like on the 20th floor, huh? Elevator.
Yes.
So final velocity V is 0. Initial velocity is 1.5 square. So the deceleration there is 1.5 square. Divide 4, huh? Which is 0.5625. 0.5625 meter per second square, and with a negative sign indicating that is a deceleration.
Yes.
The third part, change color again. The third part here is also decelerate. Let's go. This is A2. This is decelerate A3. A3. Calculate it similarly, huh?
Yes.
But I like you to do it yourself. Make sure you can do that, because watching is the worst way of learning. Everything you want to be improved, you need to practice. Distance is again 2 meter. The final velocity you can calculate by the slope of this graph.
Yes.
The slope here is the final velocity, which is distance. Distance is 12 again, from 12 to 0, huh? Distance is 12. And the time is from 20 to 26, that is 4 seconds, huh? The time 4 seconds. And therefore the final speed is 12 over 4, 3 meter per second.
Yes.
Slope equal to final speed, V final. So the deceleration in the third part is 3. Oh, it is accelerate, not decelerate. Accelerate, but in the opposite direction. Yeah. Yeah. Acceleration, not deceleration. 3 square minus the starting value here is 0, huh? And divide 2 times of the distance, which is 2 meter again. So that is 9 over 4. Is that
Yes.
like a decimal, limited decimal? 9 over 4, 2.25 meter per second square. Okay. Now we will convert this position graph to a velocity graph. Initially, velocity is constant, 1.5, huh? 1.5
Yes.
here. For the first 8 seconds, 1.5, draw a horizontal line to the red color, make it thicker. 8 seconds, too thick. 1.5 here, 8 seconds. Yeah.
Yes.
And then decelerate to be become 0. in 2 seconds. So that is from 8 seconds to 10 seconds, decelerate a straight line down, huh?
Yes.
And then increase the velocity again, but in the opposite direction, backward, huh?
Yes.
With the acceleration, which is higher mean greater slope, velocity now becomes negative and increases to the new value of 3 meters per second, negative here in 2 seconds here. After 2 seconds, meaning from 10 to 12, increases the speed from 0 to 3, but minus 3. So the part here with the higher slope, you see?
Yes.
Slope there. And finally, constant velocity and negative till the end, 26 seconds. Another horizontal line. There. Okay, so this is the final answer. Okay.
Yes. I have a question. What time do you finish?
It's about 11 now.
Yes.
Your mom asked me for 2-hour session each, right?
Oh.
2 hours, 3 hours?
I don't. Yes.
Let me check the message. I remember that 2 hours, but I'm checking. Yeah. She told me that the session is from 9 to 11 a.m. every Monday, Wednesday, and Friday.
Okay.
So it is about 11 now. I will send you the recommendation for the practice question, including multiple choice and free response.
Yes.
For the free response, I will type the assignment on the Kakao Talk and also on this learning plan. We have very limited time to cover all the topics, so you need to practice yourself a lot.
Yes.
Okay. For the pre-response questions, 142. Please do this one. Write it on your notebook and do the 1940 here about the projectile motion for the free response. Okay. If I find other free response question related to this topic, I'll send you later.
Yes.
For the multiple choice questions, 28. Okay. Please do to the end, number 50 here of this document 500 5 step to AP. Okay.
Yes.
We've been to 26 or 27 so far. So please do the rest to the question 50. Okay. Homework, type that. And this is the link, the document that I wrote the note on.
Yes.
No, not this one. What's that? Free response. This one. Kinematic multiple choice worksheet. Oh, it's not multiple choice. I need to move it somewhere else. Okay, see you later on Wednesday.
Okay, thank you.